Hello students, and I welcome you to this module of Home Tutors. This module of Home Tutors is on advanced trigonometry, and your facilitator is still Kayode Babatokwe. As a prerequisite, I will appreciate if you can go through our module on trigonometry before this module on advanced trigonometry. On the module of trigonometry, you will have dealt with the basics of trigonometrical ratios, the sine, the cosine, and the tangents. You will also have dealt with the proof of and the application of the sine rule as well as the cosine rule. You will also have dealt with angles of elevations and depression, as well as some basics of Pythagoras theorem. Also, in the basic trigonometry course, you will also have dealt with what we call the special angles. It is very good for you to go through this course before the course on advanced trigonometry, because a lot of the things we will be looking at in advanced trigonometry will be based on your prior knowledge and understanding of certain basic concepts of trigonometry. The outline we will be considering in advanced trigonometry are trigonometrical identities, double angles, sum and differences of trigonometrical ratios, half angles, and the T formula. Don't forget that, as is customary in all of our Home Tutors programs, after taking you through basic principles of each of the courses, we solve for you all the questions on that topic in your new general mathematics, as well as all occurrences of questions under that topic in WAEC and JAMB since 2000 till date. Good. Now let's proceed. Trigonometrical identities. The trigonometrical ratio of sums or differences of two angles can be given in terms of the ratios of the individual angles. For example, the cosine of a sum of angle is given by cos theta plus phi, can be expanded to give cos theta cos phi minus sin theta sin phi. We will try to go and prove this, but then basically, rarely will you be asked to prove it. What we just need to know is the application of the concept. But just for a very ambitious, very curious students, I will go ahead and prove one of these trigonometrical identities, and then you can expand the proof to prove all the other ones. Now, considering the triangle AXC on your screen, triangle AXC and triangle BXE. These two triangles are identical because in these two triangles, angle A is equal to angle B and is equal to theta. Why did we say angle A is equal to angle B? Consider these two triangles, AXC and BXE. The first point to note is that this angle is a right angle, so also this angle is a right angle. All right, so these angles are equal. So also these two angles are vertically opposite. Therefore, according to the basic principles of geometry, vertically opposite angles are equal. So if you have two triangles and two of the sides are already equal in quantity, definitely the third sides must also be equal. Therefore, angle A and angle B are equal, and let us denote it by theta. Hence, therefore, we see that cos theta plus phi, you see this is theta, this is phi. Therefore, cos theta plus phi, that is this entire angle. Remember, from basic trigonometry, we said that cos, that is cosine, equals to adjacent over hypotenuse. Therefore, cos theta plus phi equals to AC over AB. I hope that is clear. Adjacent AC over AB. This is based on the triangle ABC. However, the line AC can be expressed as AF minus CF. Therefore, cos theta plus phi, which is equal to AC over AB, can also be expressed as AF minus CF, that is AF minus CF divided by AB. However, CF is equal to DE. CF is equal to DE. Therefore, cos theta plus phi, which equals to AF minus DE over AB, can be expressed as AF over AB minus DE over AB. I hope you understand how we got DE here. From the basic equation here, we have AF minus CF. However, we also said CF equals to DE. So we can use DE to replace CF. And if we expand out this expression, we will have cos theta plus phi is equal to AF over AB minus CF over AB. However, CF equals to DE. Therefore, CF over AB can also be expressed as DE over AB. Now, from the figure that you are seeing on your screen, cos theta is equal to AF over AE. Did you get that? Cos theta is adjacent over hypotenuse. Adjacent is AF over AE. That is based on the triangle AEF. Okay? That is, from the triangle AEF, cos theta equals AF over AE. Therefore, if you make AF the subject of the formula, you will have AF equals to AE times cos theta. Okay? Similarly, from triangle AEF, you still find that sin theta, sine is opposite over hypotenuse. So sin theta will be equal to EF over AE. However, this is based on if you use triangle AEF. But then, we have proven earlier in the proof that angle theta in triangle AEF is equal to angle theta in triangle BDE. Therefore, in looking for our sin theta, let us use the triangle BDE, so that sin theta equals to opposite over hypotenuse, which equals to DE over BE. Maybe a question you will have wanted to ask: why did I choose to use this triangle and not this triangle? Anyway, when you are trying to make a proof of an hypothesis, there are certain steps that you just have to take them like that, because that is how to make the proof to fly. So I'm sure if you take some time to use another alternative in order to make the proof, for the very smart and sharp ones, you may be able to find an easier way around it, or to be able to find the reason why it is done the way I'm showing you. But basically, that's why I said, rarely will you be expected to be able to prove it. But if you have to learn how to prove it, you have to learn the standard procedure. So there is a standard procedure for proving it, and that you must know. So in the standard procedure for proving trigonometrical identities, this is how it is done, and that's how you have to learn it. Therefore, sin theta now from triangle BDE is given as opposite over hypotenuse, which is DE over BE. In this expression, if you make DE the subject of the formula, you will have DE equals to BE sin theta. This therefore means that cos theta plus phi which is equal to AF over AB minus DE over AB. Do you still remember that from this expression? Now, you can now re-express it as, because you have found out now that AF equals to AE cos theta. So, you can replace AF in this expression with AE cos theta. So, instead of AF over AB, you now have AE cos theta over AB. So, also, DE over AB can be expressed as BE sin theta over AB, because you have seen from this expression that DE is equivalent to BE sin theta. But from triangle ABE, you will realize that cos phi is adjacent over hypotenuse, which is AE over AB. That is, cos phi equals to AE over AB. So also, sin phi is opposite over hypotenuse, which is BE over AB. Now, where does that take us? Therefore, if we substitute cos phi for AE over AB in this expression, you will now be left with cos theta cos phi. Did you get that? You already have this expression that's AE cos theta over AB. However, from here, AE over AB is equal to cos phi. So, you can remove AE over AB and put cos phi. What does that leave you with? It leaves you with cos theta cos phi. Cos theta cos phi. So also, you can replace BE over AB in this expression with sin phi, because you have found out that BE over AB equals to sin phi. So therefore, by substituting this expression into this equation, you can find out that cos theta plus phi is equal to cos theta cos phi minus sin theta sin phi. This is what is called trigonometrical identities. Like I said, you really will need to know how to prove it. But then, for those who are really curious and who want to know how to prove it, I do hope I've been able to help you in a way at least to have some insight into it. But I know if you settle down, you'll be able to understand it better, or perhaps find an easier way to go about the proof. But then, beyond the proof, you have to know the statements of the trigonometrical identities. And these are the statements of these identities. One, that cosine of a sum of angles is equal to the product of the cosine of the angles minus the product of the sine of the angles. That is, cos A plus B equals to cos A cos B minus sine A sine B. Similarly, cos A minus B, that is the cosine of a difference of two angles, is equal to the product of the cosine plus the product of the sine of the two angles. That is, cos A minus B is equal to cos A cos B plus sine A sine B. 3. Sine A plus B is equal to sine A cos B plus cos A sine B. And 4. Sine A minus B is equal to sine A cos B minus cos A sine B. These are the things you have to use again and again until you get used to them and are able to recollect them offhand for use when it becomes necessary. Also, there are two more left that you need to know, but then quickly we can derive them from the basic ones you already have. Now, also from the basic course in trigonometry, you have been told that tan theta equals to sine theta over cos theta. That is, the tangent of an angle is equal to the ratio of the sine of the angle to the cosine of the angle. Therefore, tan A plus B will be equal to sine A plus B over cos A plus B. Now, we can express sine A plus B based on what we just learned. Sine A plus B is sine A cos B plus cos A sine B divided by cos A plus B will give you cos A cos B minus sine A sine B. So, this expression is equivalent to tan A tan B. However, we can factorize this further to keep it a bit simpler and neater. Therefore, let us try to divide through by cos A cos B. You might ask me, why did we choose to divide through by cos A cos B and not sin A sin B? Like I said, that is how it is done, and if you need to learn how to prove it, you have to just learn the procedure for proving it. If you are divided through by any other thing, you will still have got an answer, but the answer you will get will not look like what is popularly used. So if you want to get the popular expression, you have to use the same procedure with which it is proved. However, you can divide with any other thing and you will still be able to get your answer. But the final expression you are going to get will not be immediately obvious based on what is generally known by everybody. Therefore, by procedure, we divide through by cos A cos B. So if you divide through both the numerator and the denominator by cos A cos B, what are you going to find? You are going to eventually come up with sin A cos B over cos A cos B plus cos A sin B over cos A cos B. What will that give you? Sin A cos B over cos A cos B is equivalent to tan A. How did I know that? Because cos B, we cancel out cos B, and what you will be left with is sin A over cos A, and sin A over cos A will give you tan A, plus cos A sin B divided by cos A cos B. Cos A, we cancel out cos A, and what we'll be left with is sin B over cos B, and sin B over cos B is equal to tan B. Okay? Now, divided by cos A cos B over cos A cos B, that is 1. That gives you 1. Minus sin A sin B over cos A cos B. Nothing is going to cancel out at this point, so you are going to be left with sin A over cos A times sin B over cos B. Sin A over cos A is what? Is tan A. And sin B over cos B is what? Is tan B. So you are going to be left with tan A tan B. This is a popular expression for the trigonometrical identities for the tangents of a sum of two angles. So immediately you see this, everybody knows it, it's quite obvious. And the way we achieve this is by choosing to divide by cos A cos B. If you had chosen to divide by this, you will still have obtained an expression, but to be different than the popular expression which is used when you are dealing with the tangents of a sum of two angles. So we come to the popular equation, tan A plus B equals to tan A plus tan B divided by 1 minus tan A tan B. And then you have the closely related one, that is the tangent of a difference of angles, which you can also prove like we proved the earlier one. But then after going through the exercise, you will arrive at tan A minus B will give you tan A minus tan B over 1 plus tan A tan B. Almost similar. The difference is that when you are dealing with the tangent of a sum of angles, you have minus here and plus here. And when you are dealing with the tangent of a difference of angles, you have minus in the numerator and plus in the denominator. Good. So these are the expressions you need to get used to. These 6 identities: cos A plus B, cos A minus B, sin A plus B, sin A minus B, tan A plus B, and then tan A minus B. Use them again and again in solving problems until you get used to those expressions. You will find them quite invaluable. Now, why do we really need these trigonometrical identities? Using these identities help us to be able to find the trigonometrical ratios for angles other than 30, 45, and 60 in solid form. If you remember, one of the very final topics that we handled during the basic course in trigonometry is called special angles. The special angles are angles 30, angle 45, and angle 60. And they are called special angles because their trigonometrical ratios can be expressed in terms of surd. in surd form. I do hope and expect you know what a surd is. If not, you have to consult our module on surds. Now, for example, find the value of the following in surd form. Cos 75, cos 15, sin 105, tan 135, and sin 120. Now, we want to be able to find the value of cos 75 in surd form. 75 degrees is not a special angle. But what we try to do is to express 75 in terms of two numbers which are special angles. So 75 is equal to 50 plus 25, isn't it? But 50 is not a special angle, neither is 25 a special angle. So we can say 75 is equal to 90 minus 15, but 15 is not a special angle. So again, let's try another one. We can say 75 is equal to 30 plus 45. Voila, because 30 is a special angle, so also 45 is a special angle. So since we can find the trigonometrical ratios of angle 30 in surd form and angle 45 in surd form, now it becomes easy to find the trigonometrical ratio of angle 75 degrees, cosine 75 degrees in surd form using trigonometrical identities. By just saying that cos 75 degrees is equal to cos 30 plus 45. And remember, when you have cosine A plus B, you express it as cos A cos B minus sine A sine B. Okay, but then before we go too far, in solving questions of this nature, the first thing to do is to look at the values you are given and think of how to resolve this value into two special angles. But then, let us take a quick recap of the trigonometrical ratios of the special angle. For example, let's start with 30. 30 degrees. Sine 30 is 1 over 2. Sine 60 is root 3 over 2. Sine 45 is 1 over root 2. Or you can call it root 2 over 2. In basic surds, 1 over root 2 is the same thing as root 2 over 2. Just to mention also, in most occasions, 0 and 90 are also taken as special angles. Their trigonometrical ratios really do not come as a surd, but they come as some integers. For example, sine 90 is 1, whereas sine 0 is 0. So there are some easy to remember numbers. So at times also, 0 and 90 can be considered as special angles. So sine 90 is 1, and if we add 0, sine 0 is 0. So it's good you have these at your fingertips so that you can easily use them when you need to. Now, what about the cosine of 30? Cos 30 is root 3 over 2. Cos 60 is 1 over 2. Cos 45 is 1 over root 2, which is the same thing as root 2 over 2. And cos 90 is 0. If we add 0 to it as a special angle, cos 0 equals 1. Now, what about tan 30? Tan 30 is root 3 over 3. Tan 60 is root 3. Tan 45 is 1. Tan 90 is infinity. Okay, so now these are the trigonometrical ratios of the basic special angles. Now we go ahead to use this knowledge to solve the first problem. Now, 75 equals to 45 plus 30. That is, cos 75 will be equal to cosine of 45 plus 30. And then, using our basic trigonometrical identity, cos A plus B is cos A cos B minus sine A sine B. Therefore, cos 45 plus 30 will be equal to cos 45 cos 30 minus sine 45 sine 30. Now, going to our table of trigonometrical ratios of special angles. Cos 45 is what? root 2 over 2. Okay. Cos 30, root 3 over 2. So here you have root 2 over 2 times root 3 over 2 minus sine 45 is what? Sine 45 is 1 over root 2, or you call it root 2 over 2, okay, times sine 30. Sine 30 is 1 over root 2. So by the time you clean this up and express it in a very neat fashion, you will have root 6 over 4 minus root 2 over 4. And then you can use 4 to factorize. That gives you cos 75 equals to root 6 minus root 2 over 4. This is quite interesting. So you've been able to express the cosine of angle 75 in surd form. You might say, oh, why do I need to do this? I can always check my 4-figure table and I will still get the same answer. But the question is this: in some examinations or in some questions, it may be precised that you should give your final answer in surd form. And also in some external examinations that are objective in nature, by the time you look through the objective options, you might see that all the options are in surd form. So if you don't know how to convert those angles into something you can find its trigonometrical ratio in surd form, you will not know which is your answer. Because based on your 4-figure table, you will be using decimal numbers. So it is very, very important for you to also master the use of trigonometrical identities. And I suggest that you have to have these identities offhand. You need to be able to recall them easily for you to be able to solve problems easily also. Now we go to the next problem.